Example 6 says write sine of 3x in terms of sine of x. So sine of 3x is the same thing as sine of 2x plus x, and now I can use the sum formula for sine. So sine, cosine, and we know because it's sine, it's the same symbol. So sine, cosine, cosine, sine. Okay, so now we need to rewrite these things. I'm going to use the double angle formula for this component of sine of 2x, and we know that that's equal to 2 times sine of x times cosine of x, and then I'm going to bring down this cosine of x here, plus I'm going to now rewrite cosine of 2x using a double angle identity, and I'm going to be methodical about which one I choose because I only want this in terms of sine, so I'm going to rewrite cosine of 2x as 1 minus 2 sine squared x, and then times sine of x, like that. Okay, so let's do some simplification here. I have 2 sine of x. I'm going to multiply these two cosines together to get cosine squared x plus 1, no, let's see. I want to distribute this sine into both of these terms. So if I do that, we get plus sine of x minus 2 sine cubed x. All right, so we're getting closer to being done with this example. Almost all of our terms are sine except this cosine here, but I know I'm going to do this off to the side here. I know with the Pythagorean identity that sine squared x plus cosine squared x is equal to 1. And if I solve that for cosine, I get cosine squared x is equal to 1 minus sine squared x. So I'm going to go ahead and make that substitution now. So I get 2 sine of x times 1 minus sine squared x plus sine of x minus 2 sine cubed x. And now I'm going to distribute the 2 sine of x in. And lastly, we want to combine like terms. So this minus 2 sine cubed x and this minus 2 sine cubed x are like terms, and then we have a 2 sine x and that sine x there. So if we combine that stuff, we get 3 sine of x minus 4 sine cubed x. And now all of our terms only have sine of x in them. So this will be our final answer for this example. Example 7 says prove that tangent squared x is equal to 1 minus cosine of 2x over 1 plus cosine of 2x. Example 7 says prove that tangent squared x is equal to 1 minus cosine of 2x over 1 plus cosine of 2x. Now, we are learning about the double angle identities, so I'm going to start off with the right-hand side since we have two places where we can utilize the double angle identity. So the right-hand side is equal to 1 minus cosine of 2x, and the denominator is 1 plus cosine of 2x. And so I'm going to rewrite that using the double angle identities. And I want to be strategic about which of the 3 variations of cosine of 2x that I use. Now, I'm going to keep in mind that tangent squared x is the same thing as sine squared x over cosine squared x. And so my goal is in the numerator, I want to just be left with sine squared x, and in the denominator, I just want to be left with cosine squared x. So that's going to inform which variations I choose of the double angle identity for cosine. And so in the numerator, I'm going to choose 1 minus 2 sine squared x. And in the denominator, I'm going to choose 2 cosine squared x minus 1. And so this step is by the double angle identity for cosine. And then if I do some algebra, if I distribute in this minus 1, then I'd get 1 minus 1 plus 2 sine squared x, and the 1 and the minus 1 will cancel out. So I'll just be left with 2 sine squared x. And then in the denominator, we'll have this plus 1 and this minus 1 cancel out. And so we'll be left with 2 cosine squared x. And so this was like distribution and combining like terms. And then the last thing, well, I guess we have 2 more steps. The 2's will divide out. So we'll have sine squared x over cosine squared x. So this step was brought to you by division. And then the last thing is that that equals tangent squared x, which is equal to the right-hand side. So we are done there, and that was through the reciprocal identity. So that's it for example 7. Here we have the power lowering identities or the power lowering formulas, and we actually just proved the one for tangent in example 7 that we just did. So you can do the other ones on your own and see that those are true as well. In the meantime, let's go ahead and work on example 8, which says to prove that sine squared x times cosine squared x is equal to 1/8 times the quantity 1 minus cosine of 4x. Now I'm going to start off with the left-hand side here. And notice that these both have powers of 2, and so I can use this identity and this identity. So I'm going to replace that with 1 minus cosine of 2x over 2 times 1 plus cosine of 2x over 2. And so this step was brought to you by the power lowering identities or formulas. You can call them either one. Okay, so now I'm going to do some multiplication, and I'm going to multiply these two fractions together. And in the denominator, I'm going to have a 4 since we have 2 times 2. And in the numerator, I'm going to need to FOIL 1 minus cosine of 2x times 1 plus cosine of 2x. And notice that that is a difference of squares. And so that's going to multiply to 1 minus cosine squared of 2x. And I can factor out a 1/4 and just write this as 1 minus cosine squared of 2x like that. And on this thing here, I can use another power lowering formula. And if I did that, I'd get 1/4 times 1 minus, let's see, 1 plus cosine of 2 times the angle that we have inside, which is 2x like that, all over 2. So that step was also a power lowering formula. Okay, now we got to do some algebra for us. We have 1/4 times 1. I'm going to distribute that negative sign, and I'm also going to, at the same time, split this into two fractions. So we're going to have 1 minus 1/2 minus cosine of, if we multiply the 2's together, this will be cosine of 4x, which that looks really promising because here we have cosine of 4x and here we have cosine of 4x. So it looks like we're on the right track. And I'm going to rewrite this 1 as 2/2. And if I do that, I get 1/4 times 1/2 minus, I should have had a denominator of 2 right there. So it's going to be 1/2 minus cosine of 4x over 2, like that. And now I can factor out 1/2 from inside the parentheses, since both of those things have a denominator of 2. And now the last thing I just need to do is multiply the two fractions that are outside the parentheses. So 1/4 times 1/2 is 1/8. And I don't need to do anything inside the parentheses. And notice that this is now equal to the right-hand side. And so we are done with this example.